This thing's heavy. It's made out of metal. Technically it's made out of steel, but who cares? It's still a Slinky. As you already know, Slinky has some weird physics with it. Ow. And all of that might be pretty surprising, but that's basically the most basic stuff that comes in that little $4 package that you get on Amazon. If you take into account all of that, you will find other things that are cool about this. Among other things, like those times when you immediately get out of bed and roll out of bed and slip into those little socks that you have immediately. How does that work? Physics. And then when you nail a nail into the wall and then the whole thing breaks. Physics. All of it's just physics. Like, a lot of people don't like physics. That's because they're lazy. But this is pretty basic. Some of the stuff I'm covering isn't actually physics because the border between science and physics is smaller than the nail tip. But this will be covering not just the physics of things that you find in your everyday home, but the things that you find in your home that you always, every day, is always in. This thing. How does the blood move through your body? How do you jump and not float up into the sky? How do you sneeze but your eyeballs don't pop out? How do you scratch your hair and your hair doesn't fall out? Unless you have a disease. That all comes to physicky sciencey, I don't know. Now, as you already know, in this Slinky, it is just one humongous metal pole that has been wrapped around in equal circles and strengthened in that position so that it keeps in that position, and even when you try to straighten it out, it won't straighten out. Which is good because that holds the original shape. And that also creates a little bit of tug. If you pull a Slinky a little, you'll see that there's nothing except gravity pushing it down. But then, if you actually pull it much further, you're going to feel a little tug. Not from gravity, but from the tug of the Slinky structure. It is, yes, a humongous pole. Try taking a pole of this length and try pulling it. You're not going to have a good time, because that will probably rip your hands in two. But this is almost the same thing. The more you pull, the more strength it releases, and the more it's hard to pull it apart. And the harder it is to pull it apart, the more of this happens. As you already know, if you drop a Slinky, it will come up and down because it's gravity and this tension inside of all these rings competing with each other for power. Same thing in your human body. Whenever your human body is literally doing some weird stuff like dancing or running, and then you try to immediately stop running, stop hitting the ground. Like, you gotta slow down a little. And then the only way that you'll be able to fully slow down is once you finally had the tension be defeated by either your gravity or the tension. And that's how you run and you stop. And that's why if you want to stop, unless you are not even running at all, and what will happen is very simple. As you're running, you will try to stop running, but you can't immediately stop running, or this will happen. So instead you will just slow down, taking advantage of this process to make it look more immediate. That's just a natural thing your body does. You may not notice it, but actually, the moment you get the feeling that you want to stop, your body immediately takes action and starts the process of stopping by slowing down, cooling down your breathing pattern, and finally, you stop almost instantly. But you probably already know that stuff. That's basic stuff. The things that you learn in middle school, okay? Yeah, I'm not a middle schooler, but I don't care. I'm perfectly qualified to talk about this. But I've got a question. If it's anchored in this one shape, how can you move it in these humongous formulas? That's because of the structure. Not really physics, but it's the structure of this little thing right here. The structure of it, a bunch of circles, allows it to push and pull around. If you would like to test this out, get a bunch of chains and start moving them about. You're going to see that their moving pattern is slightly similar to that of a slinky. Except for a slinky, it will eventually bounce back because it's a slinky. Why does it bounce back? The tension and the gravity, like we already covered. But there is tension and gravity inside of a chain. If you try to pull a chain apart, you will not be able to do it. And if you drop a chain, it will still swing side to side because its tension is still slightly competing with gravity. But eventually, gravity will take its hold. On a shape of a spiral slinky, it's much different. A chain is different from a slinky because a chain is multiple rings, like what's in a slinky, chained together, interlocked around. They do not have tension together because they are not fully connected, unlike a slinky. A slinky, as I previously mentioned, is a long pole bent into its perfect shape, hardened, and now it's got tension and allows it to walk downstairs. Or you could also use it for physics classes. And this is all fine until you realize the cool thing behind it. Because these slinkies are actually very important for this. If you do not actually melt it down and make it all super strong, and it would be in this shape forever. And instead of when you pull it, you get the tension. When you push it, you get the tension. These are called springs, and they are much different than a slinky. A slinky, you feel the tension come from whenever gravity and the tension is competing to see who will move. One is moving this way, one is moving that way. As you can see, it's better to see like this. They're competing and competing. One always gets the better hand, the other also gets the better hand 1 second later. It's the complete opposite with a spring. For a spring, the tension is pushing it up, but the push of your hand or maybe your finger or maybe even gravity is pushing it down. That's what makes it bounce. This also bounces, but only if you elongate it, just like what would it look like for a spring. It will still competing with each other, but these are polar opposites. But you can also see the effects of a spring like this. It will not be as strong, but you will be able to tell that there is tension pushing it up instead of down. But this is a slinky. It can't really test those types of things. It's not wired for it. Why is it not wired for it? Well, a spring that is not a slinky has been wired, hardened so that it stays in shape. When it stays in shape and it's in the curvature formation, it tends to slink around things. So if you push down on it, it's just the fact that it's shaped like this will push it up instead of down. You can test this by yourself just by grabbing a random thing that you have at home and pushing it down. You see that thing. But because of the shape and because those rings are separated by a slight narrow hollow, you will still be able to push down on it unlike any other object. But for a slinky, it's a polar opposite. If you pull on it because of the shape of it and because that at first it might seem that there's no space in between it. But if you look at the shape of it, you'll be able to see that as it is not hardened enough, not as hardened as other things like springs, you will be able to pull it apart, and there will be great holes in the middle of it. That allows for perfect movement, and it allows flexibility. This is also basically how your muscles work. Your muscles have small little strings that look basically just the exact same as this before, and then you move it. And basically, what I'm saying is that this is working in the same formula as your muscles. So, and that is weird. You're probably like, this thing's $4. How much work does it take to build this one thing? Not a lot. It doesn't take a lot of work to build this. All you need is a metal pole, bring it around, and make sure it's stretchy. That's literally all that you need in order to succeed in building this thing. But if you take into account the history of it, the learning of the physics, you need Albert Einstein, you need Isaac Newton, you need the wheel, which took 5,000 years to create, or something like that. And that is a story for another time.